folks. You just looked at 4 symmetric distributions. And since the shape is symmetric, we'd use the mean to describe the center and the standard deviation to describe the spread. So here's one of the distributions you saw. It has a mean of 55, so that's the center of the distribution. The standard deviation is 12, so that gives you a sense of the spread of this distribution. Here's another distribution it looked at. This one has a mean of 17, but the standard deviation is only 3, so a lot smaller spread. But these aren't just symmetric distributions, they're normal distributions. So they're symmetric, single-peaked, and bell-shaped. This is a formula for the normal probability distribution. Of course, I'm not going to test you on this. It'd be a lot to try to remember. But this is what gives the normal distribution the actual shape that you saw. And since every normal distribution is described by its center and its spread, you see the mean, which is the center of the distribution. That's shown as one of the red characters. The other two that you see would be sigma and sigma squared. So, of course, this is the standard deviation and variance of the distribution. The normal distribution follows the empirical rule, also known as the 68, 95, 99.7 rule. This means that 68% of the observations are within 1 standard deviation of the mean, 95% of the observations are within 2 standard deviations, and almost the entire distribution, or 99.7%, fall within 3 standard deviations of the mean. So let's go back to one of the distributions we looked at. This one has the mean of 55 and a standard deviation of 12. So if 68% of the distribution falls within 1 standard deviation, and since it's symmetric, so 34% of the distribution falls between 43 and 55. So 43 is 1 standard deviation below the mean, and 34% of the distribution is between 55 and 67. So 67 is 1 standard deviation above the mean. If 34% of the distribution falls between 55 and 67, then that means 16% is higher than 67 or above 67. Likewise, 16% of the distribution is below 43. If you add up those 4 percentages, you get 100%, because 100% of the distribution lies below the curve. Are you ready for some football? And I don't mean soccer, although I am wearing a soccer shirt today. This is the gridiron here. So suppose the weights of NFL linemen are normally distributed with a mean of 330 pounds and a standard deviation of 10 pounds. So can you figure out the percentage of NFL linemen that weigh between 310 and 350 pounds? What about the percentage of linemen that weigh less than 320? Well, so here's our distribution. So if the mean is 330 pounds and the standard deviation was 10, to go down to 310 pounds, that's 2 standard deviations below the mean. And to go up to 350 pounds, that's 2 standard deviations above the mean. And 95% of the distribution from the empirical rule falls within 2 standard deviations of the mean. So we can say that 95% weigh between 310 and 350 pounds. And if you want to break it down even further, you could say that 47.5% weigh between 310 and 330, and then another 47.5% weigh between 330 and 350. What about the percentage that weigh less than 320? So that's 1 standard deviation below the mean, and we know that 68% are within 1 standard deviation. So half of that would be between 320 and 330. Of course, the other half of that 68% would be between 330 and 340 pounds. But if you've got 34% of the distribution is between 320 and 330, half the distribution is below 330 because it's symmetric. That means you have 16% that weigh less than 320 pounds.